Hello everyone, this is again your junior high school math teacher and I'm going to discuss about the graphs of tangent and cotangent functions. After watching the video, you should be able to determine the different properties and the behavior of the graph of a circular function, particularly tangent function and cotangent function. You should also uh, you should be able also to draw the graph of such functions. In this material, you will now study the properties and the behavior of the graphs of tangent functions as well as the cotangent functions. You will also need your skills in the determination in determining the functions of special angles or multiple measures of special angles to trace the graphs of circular functions. Now let us go to the properties of the curve or function of f of x equals tangent of x. First, we have the graph, and the next are the properties that are useful in tracing the graph of tangent functions. Now, the tangent function is undefined for the formula or equation x is equal to pi over 2 plus n pi. Okay, so it means at a certain coordinate of x. Now this coordinate can be determined by this formula. X is equal to pi over 2 plus n pi, where n represents an integer. Now these values are called vertical asymptotes. So when we say vertical asymptotes, refer to the figure. These are the vertical broken line crossing the x-axis at these coordinates, and these coordinates are determined by this formula. Okay, next property, the tangent function has a period equal to p, which is pi. So when we say period, it is the length of one cycle of the graph, particularly the cycle of tangent function. Third property is that the graph is symmetric with respect to the origin. Next property, the tangent is considered an odd function, meaning if you replace x by negative x, the value of the tangent function will be replaced from positive value to negative value, as indicated by the sign from its coefficient, from the coefficient of tangent. Okay, particularly tangent of x. Now, for the property of the graph, for the properties of the graph of tangent functions such as f of x is equal to a tangent of bx, so you will notice that this equation right here is a little bit different from the one that I have discussed from the previous slide, because at this point we are now considering a tangent function whose coefficient is not just equal to 1, and the coefficient of x is also not just equal to 1, and these are a and b. Now, considering the graph of this curve or function, we have the properties. First one is the function f of x is equal to a tangent of bx has a period equal to p, which is the absolute value of the ratio of pi over b, where b is taken from the coefficient of x. Next, the asymptotes of f of x equals a tangent of bx happen at the coordinate x, which can be determined by this formula. x equals quantity 2n minus 1p all over 2, where n is an integer and small letter p is the period, which can be determined by this formula from step number 1. And the function f of x equals a tangent of bx becomes steeper as we increase the absolute value of a. Okay? Now let us have some illustrative examples, particularly number 1. Now how do we graph the function y equals tangent of 4x? So for our solution, let us prepare the Cartesian plane or the Cartesian coordinate system. We have the vertical axis or the x-axis and the horizontal axis, which is the x-axis, and the vertical axis, which is your y-axis. And we label some coordinates. Okay. So we have 1, 2. Okay, yung pagitan nilang dalawa, merong 4 units. Same thing with those coordinates of y below the x-axis. So 0, actually this is negative 1, this is negative 2. Okay? And now for every 4 unit, we have pi over 8. You add another pi over 8, that is 1/4. Then another pi over 8 from 1/4, we have 3 pi over 8 and then pi over 2. Okay. So for every coordinate of pi over 8, there is a corresponding 4 units. Okay. Yun yung interval, no? Now, let us consider the following properties. First is the period of the given function can be determined by the formula P equals the absolute value of pi over b, which is taken from the coefficient of x, which is 4. So that is pi over 4. So basically, one cycle of this function, of the graph of this function, has a length of pi over 4. So that is what we meant by the period. Then for letter B, the asymptotes occurred at the coordinate x, which can be determined by the formula and substituting the necessary values. So we have x equals 2n minus 1 quantity times p all over 2. So this is the period. Then we simplify the result. We have pi over 8 times the quantity 2n minus 1. Again, n represents an integer. Then for letter C, the graph of y is equal to tangent of 4x can now be traced. So first, we need the asymptotes. Yan, ito yon. Okay? So, making use of this formula, so n is 0. Okay? So this will become 0, then 2 times 4 is 8. So the first one is pi over 8. Then if from 0, this time we considered the value of n as 1. So that will be 1. 2 minus 1 is 1. Okay. So 1. So pi over 8. Dito pa rin yan. So basically, n here is 1. So we get the asymptote that will cross the x-axis at this coordinate. Now the next asymptote can still be determined by this formula, but this time n is 2. Okay, so 2 times 2, 4, minus 1, 3, then 3 pi over 8. Ayun. Okay, yung ganun lang. Now, or kahit dito lang. Then we can now graph the tangent function. And this is the graph looks like. Yun, okay? So this is the graph. Next, about this one. About the graph of y equals 4, negative 4 tangent of quantity 2x plus pi. Now first is, we need to determine the period. So that is equal to the absolute value of pi over b, where b is taken from the coefficient of x, so 2. So our period, or the length of one cycle, is equal to pi over 2. Then the phase shift is determined by this value. Okay, wait. Okay, so I just corrected the formula for the phase shift. Before it was positive c over b, but actually it's negative c over b. Now, substituting the value of c and b, so we have negative pi over 2. So negative indicates that the movement of the graph is to the left by pi over 2 units. Then, the asymptotes occurred at where? Okay. So basically, uh, x plus pi over 2 equals quantity. Now, okay, 2n minus 1 times the period, I guess. Yes, it's pi over 2 all over 2. Then, pi over 2 transposed to the right will give us this quantity. And if we're going to simplify this, it will give us pi over 4 times the quantity 2n minus 3. Then, of course, n represents an integer. Then at this point, let us graph the given function y equals negative 4 tangent of quantity 2x plus pi. Okay. So let us label along y-axis the coordinates 4 and 8 above the x-axis, and below the x-axis is negative 4 and negative 8. Then along the x-axis are these coordinates: pi over 4, pi over 2, 3 pi over 4, and pi. Then we draw some vertical broken line which serves again as our asymptotes. Then the next step is what? We draw the graph like this. Okay? Ayun. So there you are. Now this is the graph of tangent function whose equation is y is given as y equals negative 4 tangent of quantity 2x plus pi. Okay. Okay, I think we're done with the discussion about the graphs of tangent function. And since we are done with the graphs of tangent function, let us proceed immediately this time with the discussion of the graphs of cotangent functions. Okay. Particularly when it comes to the properties of this function, f of x equals cotangent of x. So I'm going to present the illustration of the curve or the graph of cotangent of x. Okay. And the properties are the following. The cotangent function is undefined for is undefined and and it happened at the coordinate x, which can be the which can be determined by by this formula: x is equal to n pi, where n represents an integer. Now these values are called the vertical asymptotes. Okay? So kung saan value ng x nagkaroon ng undefined, so dun makikita yung vertical asymptotes. This one, the broken vertical line. Okay? Next. Now the cotangent function has a period equal to pi. Then the graph is symmetric with respect to the origin. The tangent function is an odd function, which means that if x is replaced by negative x, the value of the function will change from positive to negative. Okay, so particularly negative cotangent of x. And with that, okay, so we now proceed this time with the properties of the cotangent function, wherein the coefficients a and b now have values other than 1. Okay, so this is the graph, and we have the properties. The first one is the function f of x equals a cotangent of bx has a period equal to the absolute value of pi over b. And the asymptotes of this function happened at coordinate x, which can be determined by the formula x is equal to np, where n is an integer and p is the period. Then the third property is that the function f of x equals a cotangent bx becomes steeper as the absolute value of a increases. Okay? Next. Let us have some examples. Say we are asked to graph the function y equals cotangent of 2x. Okay, so the period of this given function can be determined by the formula pi over b, and b is taken from the coefficient of x, which is 2. Therefore, the length of one cycle of this function, of the graph of this function, is pi over 2. Then the asymptotes occurred at coordinates x determined by the formula n equals p, which is equal to pi over 2, where n is an integer. Okay, then the graph of cotangent 2x can be traced like this. Yon. Okay? So this is the graph of cotangent 2x. Now, if you don't have any question, we now proceed to the next slide for our next example. How about this one? Y equals negative 2 cotangent of 1/2 of x. Okay, let us get the period. So that is pi over b, which is 1/2. So that is 2x. Then the asymptotes happened at coordinate x determined by the formula x is equal to n pi, where pi is 2 pi. Okay, and n represents an integer. Then the graph can now be traced. First is we label the necessary coordinates along the x and y axis. Yeah. Okay. Then we trace the graph, which is your y equals negative 2 cotangent of 1/2 of x. Okay. For our next slide, We have example number 3. How about the graph of this function? So this time, from this example, we are now considering the phase shift or the horizontal translation. Okay, let us consider the following properties. First is the period. Using the formula that we have 2 pi, and the phase shift is determined by the formula negative c over b, so that is negative of negative 2 pi over 1 half, so that is positive 4 pi. So therefore, the graph is moved by 4 pi units to the right. Now, so the asymptotes are, okay, so yung x, dahil move to the right, ito ay magma-minus tayo ng 4 pi from the formula. So, NP, where P is 2 pi. Then, simplify. Okay, negative 4 pi transposed to the right. So, that will give us x is equal to 2 pi equals n, quantity n plus 2. Ayan. N, again, is negative. Therefore, we trace the graph. Yun. Then, if n equals 0, so that will give you 4 pi. Okay. So, but if n is 1, so that is 3 times 2, 6 pi. Okay, so, ito mangyayari, no? Ayun. Then, the graph can now be traced like this. Yun. Yun. Okay? Next, for our fourth example, how about the graph of this given function? Okay, the period can be determined, so that is pi over 4. And the phase shift can be determined by this formula. Okay. Wait lang. Now, for the phase shift, we have the formula negative c over b. And c is pi while b is 4. So, we have negative pi over 4. Meaning, the graph is shifted to the left by pi over 4 units. Okay? Ayan. Now, for the asymptotes, we can get the asymptotes, and at the same time, we adjust the position considering the phase shift. So that is added by the phase shift value, which is pi over 4. Then, transpose pi over 4 to the right. So x can be determined by this value, pi over 4 times the quantity n minus 1. Where n is again representing an integer. Now, for the graph, let us prepare the Cartesian plane. Yan. So, pi over 8, pi over 4, 3 pi over 8, pi over 2. Yan. Okay. So, the period is pi over 4. Yan. Then, we trace the graph like this. Okay. And that is the curve of this given function.